Okay, common factors. Common factors means I'm going to be factoring something out. Factoring really means dividing something out. The greatest common factor of two numbers is really the greatest or the largest factor that can be divided out of both numbers. Can be divided out of both of them. So there's going to be more than one. And you know what? It's usually going to be smaller than both numbers. Well, it could be equal to one of them, but it certainly can't be bigger. So for example, if we had 16 and 24, I know they're both divisible by 2. Yeah, sure. Well, they're also divisible by 4. So the greatest common factor, 4 is bigger. Oh, actually, you know what? I could divide out 8. This is 8 times 2, 8 times 3. The GCF is actually 8. Now, 2 and 4 are factors. Yes, they're common factors, but the greatest common factor is 8. It's the greatest one that'll come out of both of them. And notice 8 is smaller than both. Okay, well, the least common multiple, well, this one is the first multiple that is shared by two terms or two numbers. And you know what? It's usually greater. Oh, yeah. It has to be bigger than... So, for example, let's say we had 16 and 24. Okay, yeah, okay. The multiples of 16, usually what we do is we start with the bigger one. You start writing off multiples. 24, 48, 24 times 3 is 72, times 4 would be 96. Oh, 16 will divide into 96. Yeah. So this is the least common multiple. So in other words, it's the first number that both of them will divide in. Yeah, because 24 will go into that 4 times. 16 will go into that 6 times. Okay. So when we're talking about the prime factorization of something, the prime factorization usually has to do with expressing. So this is expressing as a product of prime numbers. Remember, prime numbers, that means 2, not 1, 3, not 4, 5, not 6, 7, not 8, not 9, not 10, but 11, 13, 15, 17. Yeah, those are the prime numbers, right? So these are numbers that have exactly 2 factors, 1 and 2. That's it. Those are the only factors. So usually what we did before is we did like a factor tree. Oh yeah, I remember like 120. Well, that's 10 times 12, which is 2 prime, times 5 prime, times 3 prime, times 4. 4 is 2 times 2. So the prime factorization is 2, 2, 2, so it's 2 cubed, times 3, times 5. See, I read it as a product. That means I'm multiplying these together. So if we're talking about prime factorization. So if we wanted to find the GCF of these two, now notice these are not just numbers. They also have X's and Y's and stuff in them. Okay, so we could do the prime factorization. Okay, well, 16x squared, really that means 16 is 2 times 2. That's 16x squared y. That really means 2 to the power of 4 times x squared times y. All right, there's 2 x's and there's also 1 y. 24, hang on, that's 8 times 3, right? 2 cubed. So 24x squared y, I could write that one as 2 cubed times 3 times x squared times y cubed. Okay, so what do they have in common? Greatest common. The greatest thing they have in common with the 2's is 2 cubed. Because there's 3 of them common. There's no 3 here, so it's not common. X squared, and y, there's only one y here, so y to the power of 1. So in other words, the greatest common factor of this one would be 8x squared y. Now, that's probably the easiest way of doing it, by writing it out as the prime factors. We could also list out the different factors, like all the different numbers that'll divide into 16x squared y. Well, what are all the different factors? 2 divides in, so does 4, so does 8, so does 16, well, 1, but 1's not going to be the greatest. 1 times 16, 2 times 8, oh yeah. And there's also x will divide in, and there's x squared. X squared is also a factor, and y. Okay, so if I look at the other one, 24x squared y cubed, the factors there are 1 and 24, 2, 12, 3, 8, 4, and 6. Okay, so I can see all the different factors. X divides in, so does x squared, so does y squared, so does y cubed. Okay, so which one is greatest of all of these? 1, 2, 3 is not common, 4, 8. 8 is common. X squared is common. And y to the 1. So there it is, 8x squared y. See, it's the same thing. You can do it either way, but this might be faster when you write out the prime factorization. Okay, so we're going to be talking about the GCF of a polynomial. Polynomial really means many terms. Okay, I remember that. The GCF of a polynomial is the greatest factor, so the greatest common factor that will divide out of all the terms. So that can divide out of all the terms. Now, if it's a polynomial, that means it may have coefficients. Those are numbers. Coefficients. And it could have variables. Okay. So there could be x's in there too. Okay. Well, let's see. So if I want to factor the GCF out of a polynomial, here's what I want to do. So I want to write if I could write the GCF out front, because I'm going to divide it out front, and I'm going to introduce brackets. What? Brackets. Hey, how you doing? I'm a bracket. Okay, here's what this means. Factor these. So what do they have in common? 5, 10, 20. I know they're all divisible by 5. What else? X to the 5, x cubed, x to the 1. Well, common to all three of them is just 1x. So 5x is the GCF. I'm going to write that up front, and I'm going to put in brackets. So here's what I'm doing. I'm dividing it out. When you factor, you're dividing it out. So 5x to the 5 divided by 5x. 5 divided by 5 is 1. So 1, x to the 4. You don't really need to write the 1. Okay, what else? 10 and 5. When I divide that out, I'm left with 2. X cubed. When I divide out 1x, I'm left with x squared. See, when I'm dividing out, I'm subtracting off. 20x to the 1. So 20 divided by 5 is 4. X divided by x is really x to the 0. I don't need to say x to the 0. Boom. There it is. So I put in my brackets. There's the GCF. And there's what is the polynomial left over when I factor it out. So this is considered to be factored because I've divided out this. Okay, let's try it again. 7, 24. Okay, I know the common is 7. A squared, a to the 1, a to the 1. So there's only one a common, so I can take out 1a. B to the 1, b, b. Okay, they all have b's, so I can divide out a b. That's what I'm dividing out. So 7a squared b, when I divide out 7, 7 divided by 7 is 1. A squared divided by a is just 1a. B divided by b is just a. Done. Minus 28 divided by 7. So that's 4. A factored it out. B factored out. Just 4. Plus 14 divided by 7 is 2. A is factored out. B squared. When I factor out one of the b's, I'm left with 1b left over. So there's the polynomial, and there's the greatest common factor. I've divided it out front. So let's write these in factored form. What do you mean? Well, I've got these here. Notice that here I divided out x because it was common to both. See what's common here? It's not just a single term, it's a binomial. It's x minus 4. It's common to both of them. So I can factor that out front. So x minus 4, I'm going to factor it out front. That's going to be my GCF out front. GCF. And when I factor it out, when I divide it out, I'm left with 3x. When I factor it out of here, I'm left with plus 5. Hey, this looks familiar. This looks like multiplying out polynomials. In fact, if I was to multiply this all out, remember doing FOIL, first, outsides, insides, last, I would end up with something that would be the same as this. If I was to expand this all out, you would get the same thing. But this is considered to be factored because when you're factoring, it means you're dividing things out. Okay, what about this one? Yikes. This one's a little bit harder. There's nothing in common. This one has a y, that one doesn't. This one has a y, that one has a y. I don't think there's anything I can divide out of all of them. However, I do recognize something. See this? Y squared and 8y, they both have y's. See this? These both have 2's. This is called factoring by grouping. I'm going to factor the first two. So if I divide out here, what am I left with? Divide out a y, I'm left with y plus 8x. I'm going to factor these two. What do these two have in common? Well, they have 2. I can divide out 2. When I divide that out, 2y divided by, this is just y, plus 16x divided by 2 is 8x. See that? Now they have a binomial that's in common. So that's a common factor between both of them. So that is going to get factored out front. Y plus 8x. And when I factor it out, I'm left with this one and this one, the y and the plus 2. So I'm going to introduce brackets, y plus 2. So if I was to expand this all out, I would probably end up there. You know what? I'm going to do that. Let's just quickly do that. Let's do FOIL. Y times y is y squared. Y times 2 is plus 2y. 8x times y is 8xy. 8x times 2 is 16x. That's what I have. See? Y squared, 2y, 8xy, 16. So multiplying out by FOIL and factoring are opposites. Factoring is the opposite of expanding. In other words, if you were to multiplying them all out. So factoring is division. Expanding, in other words, multiplying it all out, is multiplication. Okay, so there's the assignment to give it a shot. We'll see how things go.